So let's move on with the next question, and we have in the next question log of x to the base 7 and the whole base is 5. Now, do you remember that if you want to get the derivative of log x, we all know it is 1 upon x. But do you also remember that the derivative of log x can be written as 1 upon x only and only if the base is e. The base has to be e. So that means I can write, if y is equal to log x and I want to get the derivative dy by dx, the base of this log has to be mandatorily e. If it is other than e, then the derivative is not 1 upon x. You got to remember this point very well. The derivative of log x is 1 upon x only and only if the base is taken as e. If it is not e, if the base of the log is not e, the derivative is not 1 upon x. So derivative of log x, it is 1 upon x only and only when the base is taken as what? E. So now I say we have the question y is equal to log of, again, log of x to the base 7 and the whole base is 5. So if I say differentiate both sides with respect to x, I will write dy by dx is equal to d by dx of log of x to the base 7 and to the whole base you can write 5. Now, what's the first function that you encounter? You encounter the first function as log, isn't it? Derivative of the first function that you see is log. But this log has what base? The base is 5. The base is not e. Whatever is present inside, it is a term of x. So I'm going to consider this as u. So that's log u. But the problem is log u does not have base e. The log u has what base? The base is 5. So I need to take care. Now there is one concept on logarithms called as change of base theorem. So this is very important, change of base theorem. That is what we are going to apply in this particular question. We have log of x, or let us say log of, for that instance I will write log of a to the base b. I have a term log of a to the base b. So log of a to the base b can be written as log of a upon log of b to some common base c. So that's what the change of base theorem is. Log of a to the base b is taken as log of a upon log of b to some common base c. So now here if I try to apply the same concept, this entire thing has been taken as something in x, isn't it? So that's, I'm going to call it as u. So that's log u to the base 5. So I'm going to write it as d by dx of log x to the base 7 upon log of 5 to some common base. I'm going to take the common base as e. I have taken the common base for both the logs as e. Now if you observe derivative, there is something in x and the denominator is log of 5. This is entirely a constant term. Log of 5 is a constant term. So let's take it outside. So 1 upon log 5 to the base e is taken outside, and we have derivative of log x to the base 7, and the entire log now has base e. Now you can definitely take the derivative because log of something of x, that is log u, and the base is e. So log u, base is e. Derivative is 1 upon u and derivative of u again. So I write 1 upon log 5 to the base e. Derivative of log x is 1 upon x, but it is not x. So I'm going to treat it as log u. Derivative of log u is 1 upon u. So log of x to the base 7, isn't it? Log of u, 1 upon u. And again derivative of u. So log of x to the base 7. So now I see log of x. Can the derivative be 1 upon x? Absolutely correct, isn't it? The thought has come to your mind that log of x derivative is 1 upon x only and only the base is e. The base has to be e. The base is not e here, it is 7 here. So the first thing I should be doing is changing the base, isn't it? So let's change the base. So I'm going to write 1 upon log of 5 to the base e. then 1 upon log of x to the base 7, and I'm going to change the base here. So derivative of log of x upon log of 7, and I put the common base as what? E. So I'm going to put the common base E. Now log of 7 to the base E again is a constant. So where does the constant go? The constant will go outside the derivative. So it goes outside the derivative, and what is left inside the derivative? Derivative of log x. So if you know, derivative of log x is 1 upon x. So I'm going to write my answer. So I hope you have understood the change of base theorem, and more importantly you have also noted down the change of base theorem. So I'm going to remove this change of base theorem from here. Let's remove it from here so that we have some space to write our remaining part of the solution. So I'm going to get my solution as, see, let's write the solution. I have 1 upon log of 5 to the base e. So let's write 1 upon log of 5 to the base e, isn't it? Then I have 1 upon log of x to the base 7. So I write 1 upon log of x to the base 7. Now the base is 7. Again I can make use of the change of base theorem. So here I can write log x upon log 7 to some common base e. So I'm writing it as log x upon log 7. From here the derivative, the log 7 has come outside the derivative. So I'm going to write 1 upon log 7 to the base e. It has come outside the derivative, and what is left inside the derivative? Only log x is left, and the derivative of log x is going to be what? 1 upon x. So I write 1 upon x here. Now you must have observed, you must have realized that log of 7, this term can be cancelled from the numerator and denominator, isn't it? So I'm going to cancel this log 7 and log 7. So my final step, the final answer is going to look like 1 upon, I'm going to write the x at the beginning, then you write log of 5 to the base e into log of x to the base e. So that is what the answer for the given question would look like. We will move to the next question now.